I'm Anil Kumar. Welcome to my series on linear relations. In this video, I've taken up 5 examination style questions. They are related to parallel and perpendicular lines. I'd like you to pause the video, read these questions, and answer them. In case you want to learn from me, you can always send me an email on the given address. Also, check our website for the new videos. Let's go through these questions. I'll provide their solution within a minute. Question number 1 here is test question, parallel lines. Find equation of line parallel to 3x minus 4y equals to 12 with x-intercept at 6. Question number 2 is based on perpendicular lines. It is find equation of perpendicular line to 2x plus 3y equals to 15 with same y-intercept. Question number 3, tangent to circle. Find equation of a line tangent to circle x square plus y square equals to 25 at 3, 4. The point 3, 4 will lie on the circle. Also note that x square plus y square equals to 25 is a circle with radius of r. R in this case is 5, right? Radius of 5 and center at 0, 0. So let me write down here r is equal to 5 here, correct? 5 square is 25. Question number 4 is related to rhombus, and that is where we have some tricky questions based on parallel and perpendicular lines. Let diagonal of rhombus ABCD with vertex A, which is at 1, 2, bisect each other at P, 3, 5. Based on this, we have two questions. A, find the coordinates of the point C diagonally opposite to the vertex A. And part B is find equation of the other diagonal of the rhombus. Question number 5. This is based on a rectangle. Rectangle ABCD is defined with vertex A 0 minus 3, B PQ, C 12, 13, and D MN. So we don't know the vertex B and D. Find the coordinates of the point B and D if the diagonal BD is parallel to the x-axis. So very important to note this condition if the diagonal AB is parallel to the x-axis. So once again, you can actually pause the video here, answer these questions, and then look into the solutions. Now let us see how to solve these questions one by one. Let's begin with the parallel line. As we solve these questions, we'll also try to understand a concept so that we can easily solve them uh, in the test in the least amount of time, right? So the strategy here is solution in minimum time, right? So that is the strategy. Let's see. Solution in minimum time. That really helps when we are working with multiple choice questions, correct? So we'll develop a strategy here and then in between take a multiple choice test question. Okay, so the question here once again is find the equation of a line parallel to 3x minus 4y equals to 12 with x-intercepts at 6. So parallel means same slope, correct? So that is what we want. So parallel means same slope. So our strategy now is to rewrite the equation in y equals to mx plus b form, right, to get the slope. So first step is y equals to mx plus b form. So where we'll get the slope m, and then we know that the slope of the line parallel to m will also be m, correct? So that is the strategy. Now, how do we find the slope? So rearrange the equation in y equals to mx plus b form. So we are given 3x minus 4y equals to 12. Take 4y to the other side and 12 to the left side. So 4y is equals to 3x minus 12. Dividing by 4, we get 3 over 4, x minus 3. Therefore, the slope of this line is 3 over 4. Any line which is parallel to this will also have the slope of 3 over 4. So now the parallel line will have equation as y equals to 3 over 4x plus b. To find the value of b, we'll look into the x-intercept which is given to us at 6. X-intercept at 6 means x value is 6, y value is 0. Substituting 0 for y and 6 for x, we can solve for b. We get the value of b as minus 9 over 2. Substituting 9 over 2, we get our equation, which is y equals to 3 by 4x minus 9 over 2. So that gives you the equation of line which is parallel to the given line with x-intercept at 6. Now, let us rewrite this equation in standard form just as it was given to us. 3x minus 4y equals to 12. So when you multiply by 4, all the terms, what do you get? You get 4y equals to 3x minus 9 times 2 is 18. So when you rearrange, you actually get the equation 3x minus 4y equals to 18. What do you notice here? You notice very clearly that the first part 3x minus 4y is exactly same. So for any parallel lines, 3x minus 4y or in general ax plus by will be same equals to k. So that is equation of parallel lines, right? So any value of k will produce lines which are all parallel. This is very important to understand. And that gives us the strategy for minimum solution, correct? So the strategy here is what we need to do. For parallel lines has the same coefficients. So these are a and b. These are the coefficients of the equation standard form. They are same. And therefore, we could do is, when we are given the equation 3x minus 4y equals to 12, we can write another equation 3x minus 4y equals to k. These two lines will be parallel. You get the idea. So we need not interchange to slope and intercept form. So that is what we have learned here. So no need to do part A, which is changing to slope and intercept form. Straight away, you could write this as 3x minus 4y equals to k. To find the value of k, we'll use the x-intercept given to us, 6, 0. Substituting 6 for x, 0 for y, we get the value of k as 18, and therefore the equation of the line is 3x minus 4y equals to 18. You get it? So that is how we are going to do it. So once again, have a good look at this. Parallel lines will have the same coefficients, ax plus by equals to k. All these lines are going to be parallel, right? So take different values of k, sketch them just to verify, okay? Now let's take the second example, which is based on perpendicular line. The question here is, find equation of line perpendicular to 2x plus 3y equals to 15 with same y-intercept. So you need to find the y-intercept. Okay, so first let's find the y-intercept for this particular equation. To find the y-intercept, one method could be convert to slope and intercept form, which we have done here, right? So that is the method which we have done, and the method is rearrange and write what y is. 2x plus 3y equals to 15. 3y is minus 2x plus 15. Divide by 3. We get the slope and we also get the y-intercept. So we know now that the slope here is minus 2 over 3 and the y-intercept is 5. So that is how you find slope and the y-intercept by converting to slope and intercept form. Now perpendicular lines will have a negative reciprocal slope. So the line which is perpendicular to the given line will have a slope which is going to be, let me write this as perpendicular, will be 3 over 2. Negative of negative will be positive, 3 over 2, and the y-intercept we want is the same, so b equals to 5. Therefore, the equation will be y equals to 3 over 2x plus 5. And we can now rearrange and write it in the standard form. 3x minus 2y plus 10 equals to 0. What do you notice? Well, you notice one thing, that if the equation is ax plus by equals to, let us say, c, in that case, perpendicular lines will be bx minus ay equals to k. Do you get the idea? So that is how you could actually rewrite the equation. And once you do that, you can find the value of k. So for perpendicular lines, these are perpendicular lines. What do you notice? We notice that the coefficients interchange with a negative sign. You see that? And that gives us the strategy. So instead of doing with strategy 1, we should use strategy 2, which is perpendicular line coefficients interchange with one reverse sign. So you could either reverse the coefficient of x or coefficient of y. So in our case, the line given to us is 2x plus 3y equals to 15. A perpendicular line will be interchange, right? 3 for x, 3x minus 2y equals to k, and change the sign in the center for one of the coefficients. So that becomes a line which is perpendicular. Do you see that? Now we need to find the value of k using the y-intercept, which is 5. Substitute 0 and get the answer, correct? Now to find the y-intercept, we really do not have to write it in slope-intercept form, right? So, we had this equation as 2x plus 3y equals to 15. And how do we find y-intercept? To find y-intercept, we know x equals to 0. Substitute 0 here, so we get 0 plus 3y equals to 15, and that gives you y equals to 15 over 3, and the y-intercept is 5. Do you see that y-intercept of 5? So that is how you could do it without converting to slope and intercept form. So the steps here basically are: rewrite the equation of perpendicular line by interchanging or swapping the x and y coefficients, making one of them negative. Negative reciprocal, correct? And then find the value of k by substituting the point given. In this case, we have a point which is the y-intercept, and therefore we'll substitute 0 for x and 5 for y to get the value of k, which comes to be 10 minus 10. So therefore, the equation is 3x minus 2y equals to minus 10. When you rearrange, you get the same equation. They are both same, correct? So that strategy is a shortcut method of solving lines which are perpendicular. Now, let's look into more examples, and these are application test questions. Finding equation of a tangent to a circle. It is a challenge question many times. So let's go through the equation once again. Find the equation of a line tangent to the circle x squared plus y squared equals to 25 at a point P, which is 3, 5. Now x squared plus y squared equals to 25 is a circle which has a center at the origin and the radius is of 5 units length, right? That is how we get this particular circle. Now point 34 is on the circle, right? You can see 3 square plus 4 square is what? 9 plus 16, and that is equal to 25. So the point is on the circle. So this is the point P, which is on the circle. So we have verified, but no need because it's given to us. Now if I connect this point with the center, I do get this radius, correct? So the radius is connecting to the point, and definitely radius will be at 90 degrees to the tangent, and that helps us to find the answer. Clear? Now, let's find the slope of the radius first. So the strategy here is tangent is normal to the radius OP. Normal means perpendicular. Slope of the radius OP is, so you can find the slope here. The coordinates are 3, 4, and therefore the slope is rise over run. So 4 over 3. So we get the slope as 4 over 3 for the radius. Slope of the tangent, which is perpendicular, will be negative reciprocal, correct? This is perpendicular. Minus 3 over 4. And therefore the equation will be y equals to minus 3 over 4x plus b. To find the value of b, we're going to substitute the point 3 and 4. So 3 for x and 4 for y. And then rearrange to find the value of b, which is 25 over 4. And therefore the equation will be y equals to minus 3 over 4x plus 25 over 4. You can rearrange and write it in standard form. Multiplying by 4, we get 4y equals to minus 3x plus 25, or 3x plus 4y minus 25 equals to 0 becomes the answer. Clear? Have a good look. The strategy here is that tangent is perpendicular to radius. Correct. Now let's take up another example which is based on rhombus. The question here has been converted to a multiple choice question. I'd like you to apply some strategy to find this answer. Let diagonals of a rhombus ABCD with vertex A, which is 1, 2, bisect each other at P. A. Find the coordinate of the point C diagonally opposite the vertex A. We are given four choices, and B is find the equation of other diagonal of the rhombus. Four equations are given to us as a choice. So I'd like you to now pause the video, answer this particular question, and then look into my suggestions. Now here is a hint, right? So we're talking about a rhombus. Let's just make one rhombus. Let's make it like this. Okay. So means all sides are of equal length and opposite sides are parallel. We are given this particular rhombus. Here is a diagram. Let's say A, B, C, D, correct? We're given that the point A is 1, 2. So this point here is 1, 2. Bisect each other. So there's another diagonal which is from B to D, and they bisect each other at a point P, and the coordinates for this point P are 3, 5. So this is 3, 5. That is the point P. We need to find the coordinates of point C. So this is one part A. Second part is we need to find the equation of dB. So that is how you have to do it. Correct? How are you going to do it? Look here at a strategy. We want the point same distance on the same line. A to P, we know, is equals to P to C. So how will you figure this out? The strategy here is, if you want to go from A to P, then what do? You are at 1, you have to go to 3, right? So basically, you move 2 steps on the right, and then from up, you have to go from 2 to 5, 3 up, right? So what do? From A to P, the change in x value, let me write delta x, is 3 minus 1, right? Is 3 minus 1, which is equal to 2. And change in y value is what? 5 minus 2, correct? 5 minus 2, which is 3. So basically, if I add this to point P, I will get C, correct? So looking into this, what am I going to do? Point P is 3, 5, right? Now to this, I am adding 2 to x value and 3 to y value. If I do that, I get 5, 8, and that becomes the coordinate point of C. So 5, 8 is option C. You get the idea. That is how we are going to solve this question. We need not find the equation of the line and then find the distance and all that. Perfect, very easy method to do. So that is one part. Now the second part of this is find the equation of the other diagonal. So you apply the concepts learned earlier to find equation of perpendicular line. Since we know that this diagonal, the two diagonals are always perpendicular. Now you can find the equation and match it. Perfect. That is how you could do it. Now let's review our strategy of question number 4a. We needed to find the coordinates of point C, correct? We wanted to find the coordinates of point C diagonally opposite to the vertex A. So again, here is your diagram. So we have this point A and P. We want C, which is same distance on this, right? So same distance on, like an image, correct? That is what we need to figure out. That is the point C to us. How do we find? Once again, from A to P, we see that the change in x value is of 2, change in y value is 3. If I add this change to P, I get the point C. So point C is 3 plus the change in x and 5 plus the change in y, 3 plus 2 and 5 plus 3, and that gives me the coordinates of C as 5, 8. Is that clear to you? Now, in part B, we'll find the equation of the diagonal. So let's move on. So now we need to find the equation of the diagonal. To find the equation of the diagonal, first step will be to find the slope. And slope is change in y over change in x, which we found is 3 over 2. Perpendicular means negative reciprocal, so negative of 2 over 3, and that goes through the center point, which is 3, 5. Therefore, the equation will be y equals to minus 2 over 3x plus b. To find the value of b, I'm going to substitute 3 for x and 5 for y, and rearrange to find the value of b as 7. And therefore, the equation will be y equals to minus 2 over 3x plus 7. You can rearrange and then get your solution. So that is how you could actually get the solution. I hope it makes sense. Perfect. So that is how you're going to solve the question. Option D is the right option. Perfect. Now let's see the last question here, which is based on a rectangle. The question is, rectangle ABCD is defined with the vertex A, which is 0, minus 3, B is PQ, C is 12, 3, and D is MN. Find the coordinates of the point B and D if the diagonal BD is parallel to the x-axis. Now that is very critical information. How do we use this information? This is critical to answer this question based on a rectangle. So here is a diagram for you. So we have a point A, which is 0, minus 3, and we have point B, which is given C, which is given to us at 12, 13. And then we know that the diagonal BD is parallel. So we have drawn a diagonal which is parallel to x-axis. Now clearly, when you notice such things, if you look into the perpendiculars from the two, you will notice that these perpendiculars, this diagonal actually divides into two triangles, right? These are two triangles. These are triangles with equal area. That means the lengths are same for the altitudes, and that means that the diagonal must be in between the two y values. Exactly. Do you understand? That is why we are given this strategy here, and that makes sense, which is, since the diagonal is parallel to the x-axis, the y-coordinate BD should be midway the y-coordinates of A and C. Perfect. So that brings us to straight solution to find the value of Q, which is the y-coordinate of the point B. So let's find the midpoint. Midpoint between 13 and minus 3 is add them and divide by 2. So we get the value of Q as 10 by 2, which is 5. So first thing we did was to find Q. Now since it is parallel, we know M, N and Q are same, right? So parallel means the Y values are same. We know Q is equal to N, which is equal to 5. So that is what we have found here. So we are working still with point B, and here we have found that point B, Y value is 5. The second part is we know that these two will be at right angles. Since they are at right angles, we can find the slope of AB and BC They are perpendicular, and we can relate this slope with negative reciprocal. L, get the answer. Correct? Slope A to B is y2 minus y1. You know that. So slope is y2 minus y1 over x2 minus x1. Okay? So we have found the slope here, which is A to B, is 8 over P. Slope from B to C is minus 8 over P minus 12. So using the 2 points and the relation y2 minus y1 over x2 minus x1. Now these slopes are related, as you know, they are perpendicular, and therefore we can write 8 over p as equals to p minus 12 over 8. Cross multiply. When you cross multiply, you get a quadratic equation in p. P square minus 12p minus 64. This could be factored to find the answer. You get p as 16 or minus 4. So that is how you will get your solution. At times, you may have to use the quadratic formula to find the value of p, right? And therefore, we get the points as mentioned here. B is 16.5 and D, the other value of P, is minus 4 and 5. Since the line is parallel to the x-axis, the diagonal here is y equals to 5. Okay? So y equals to 5 is the diagonal. So I hope that helps you to understand how do we figure this out. That brings us to the end of the solutions of these 5 very important questions. So question number 5 is kind of extended question where we did use the quadratic formula and factoring skill. You could use quadratic formula also. And for x, right? X is minus b plus minus square root of b square minus 4ac over 2a when the equation is ax plus by, the quadratic equation will be y equals to ax square plus bx plus c. Okay? So you could use quadratic formula and find the answer. I hope that really helps. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'll be great. Thanks for your time and all the best.